Hi, I'm Scott Nimrod, and in this session, I'm going to be talking about a more, I think, advanced form of unit testing. What happens when you need to implement some type of confirmation interface, confirmation dialog? What happens when some agent of the outside world needs to be notified that if they wish to move forward, then they need to confirm that they understand what they're getting ready to do and they confirm that they want to continue. We see this all the time in applications, in trading applications. Do you really want to buy stock XYZ? You know, do you really want to withdraw this amount? Do you really want to transfer this money? Do you really want to post this? um, So I mean, there's examples everywhere, right? But how do you unit test that? I don't go to user groups as much as I used to, but um, you know, I'm sure once a month at any local user group, there's a talk on unit testing. Right? Yeah, I think it's a good thing, right? I also think it's a shame that in almost 2017 that people are still giving intro talks on unit testing to professional developers. But hey, it's a good thing, right? Because it's not mainstream still, and people are trying to help other people get up to date. So great, 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 great. All right. So, but again, I usually and I don't want to come off condescending, right? But like I want to see if there's an alternative technique. I know there is, right? But I'm curious what the presenter's alternative technique is in regards to unit testing some type of confirmation. Okay. And when I say, does anybody have any questions? Like, me. Yes, Scott. Hey, thanks. How do you unit test like confirmation dialogues? And they take a step back. They scratch their chin. They look up at the heavens. All right. They either say, you can't, and I'll just keep my mouth shut, or they say, good question. Um, you know, I'm not sure right now, but I'm gonna get back to you. I respect that one. All right. But in this one, I'm going to tell you how you do it, right? Or I'm going to provide you a technique that I use to do it. So, like, let's get started. Let's go. Let's go. Come on. Come on. All right. So, when I go to my desktop, we're going to create a project from scratch. We're going to create an application from scratch, or at least a piece of an application, a partial application. Now I think about F sharp partial application. But if you don't work in F sharp, then you don't get it. But we're gonna create a new project, right? And I said a new project. Let me put focus back on me, okay? Try really, really hard, okay? I know there's a lot of pressure, right? But try really, really hard not to focus on details of a system. I know your lead developers, I know your architects are still around. They have this insatiable desire to make upfront decisions that aren't necessary to make upfront. But because they have a certain title, a certain position, because they have certain seniority, they feel the need. And I think this is more just as a human being or as a person in leadership. They feel a need to try to create or make all these decisions up front, right? And they feel empowered by telling people what they're going to use up front, and thy shall be WPF application, thy shall be Xamarin application, thy shall be whatever MVVM framework, without even qualifying the need to have a framework, without even qualifying it. They just say, no, this is these are the frameworks that we use, right? Without really interrogating the context of the problem that we're trying to solve. All right. So with that said, don't let them manipulate you. All right. Like, push back and focus on the business domain. Focus on the core logic, right, of what you're going to build. You focus on the core logic, I guarantee you it's going to be a lot more testable. When you start pulling in all these external tools and frameworks, yes, I know they're architects for a reason. And so they try to get things done as soon as possible, but I'm telling you, if you want to write a solid, flexible, proven system, push back and say, no, I'm going to focus on the core domain, and I'm going to make sure that it's thoroughly tested, and then we're going to identify and implement the details in regards to the external interfaces. We're going to go ahead and plug in the user interface from WPF or some Android app or whatever external user interface. We're going to plug in that mechanism to our domain. Right? We're going to snap it in. Web server, the database. I don't care if it's Entity Framework, I don't know, whatever. We're going to plug it in. All right. It's not going to define our application. It's going to complement our application. That's what you tell them. Okay. So I'm done evangelizing right now, and let's go to our. Oh, how do you close this? Let's go back to the system that we're going to build. You can say my test. Okay, you call it whatever you want. All right, but understand that we're not starting off with an application. We're starting off with a test project. Okay. We don't care about it being Xamarin. We don't care about it being WPF. We don't care about it being some web application. We are here to flush out the business logic. And what grander way to flush out business logic? By not caring what type of application it is. Okay? So with that, we select the unit test project. You call it whatever you want. I'm calling it my test. And let Visual Studio bootstrap this project for us, or this solution for us, and let's get started. Now, as it's bootstrapping this solution for us, we're going TDD, test-driven development, test-driven design. You can call it whatever you want, but we're going to nail down the logic that is required first. It's going to be testable, okay? No more like, I don't know, if I had like a handkerchief, no programming blindfolded, you know what I mean? We go TDD approach. We're no longer scared to make alterations. We're no longer scared to refactor or to extend our software. We're no longer scared to fix bugs and pray to the heavens that it didn't introduce breaking changes. Like, you go to TDD approach, you don't have to behave like that. You don't have to act like a professional debugger. You spend more time building, and not debugging and does it work yet? Right? We don't want to do that, man. All right, so our solution is created, and we have a unit test project called my test, and we have unit test 1. Okay. That's the name of our test class. We can name it underscore confirmation. You can name it whatever you want, okay? Because we're going to deal with unit testing a confirmation interface for an agent of the outside world, aka a user. And we're going to call that confirmation, right? Which will be abstract for the test scenarios that deal with confirmations. And we are going to rename this test from test method 1 to confirm. Confirm confirmation. Confirm confirmation. I don't like the name of that. We'll just call it not confirm confirmation. That sounds silly, I guess. We'll call it get confirmation. All right, that probably sounds better. Okay. So that said, we have a blank test. We're using Visual Studio. Get rid of the noise. All right. If we're not using the namespace, then it should be in our code. And in here, we need to set up the structure of our test. Okay. So with that said, every test, whether it's NASA, whether it's I don't know, bomb-proofing a car, assembling an engine, whatever. Every test is going to have 4 stages. Okay, hold up. 4 stages. Hold up. 4 stages. Okay. It's going to be setup. It's going to be test. It's going to be verify. Okay. Oh, this camera is weird. Verify. And the 4th stage is tear down. Right? 4 stages. Okay. Now, people also say it's AAA. It's arrange, act, and assert. Okay. It's the same thing, except they're missing another stage, which is tear down. And as long as it's a unit test that doesn't have any static classes that have state in it, then, or static state, if I can say that, then you don't need a teardown because it's done behind the scenes by your garbage collector. Okay, your garbage collector during setup will instantiate, allocate memory for the given objects, right? The given dependencies that your test relies on, and it is going to clean all that up whenever it feels like it, when the test completes, or when at the end of, well, whatever suite of tests get executed. I'm not too confident in when the garbage collection actually kicks in for any given unit test. I would like to think that at the end of a test method execution, it will dispose of whatever it needs, as long as it's defined locally within the unit test. But I don't care, whatever. I'll get off of that. So let's go back to our test. Based on that, I said that the 4 stages of the test, let's give it some structure, is setup, test, and verify. Okay. There's also teardown. Okay. The reason why teardown is important is because you want all your unit tests to run independently of other unit tests. You don't want a unit test to basically push a side effect, or basically have a side effect that basically alters the deterministic behavior expected from other unit tests. Okay, we don't want to affect other tests. We want them to all run in isolation. Okay, that's what we strive for. All right, but again, teardown is really done by our garbage collector. I thought it was like GC. I thought GC was like the garbage collector. You know, that's the static class for garbage collector. But we don't care about that. Okay, we don't need teardown right now because it's done for us. Okay, so let's try to keep it simple. And what we're going to do in this test, remember, we're focused on the business logic. We want to flush out the business logic. We want to basically expose a confirmation to an agent of the outside world and get a confirmation from that agent. In this case, usually it's a user of our application. We want them to confirm that they really want to do this, okay? And they're either going to confirm or they're not going to confirm, right? They might cancel or they might say no, all right? And we're going to take that input and we're going to verify that our confirmation was exposed to an agent of the outside world, and that that agent of the outside world returned or answered our confirmation request, and that's what we care about. That's what this test is for. So every how do I say this? I'm an application developer, okay, desktop and mobile, and I don't care if the actual framework isn't MVVM, right? I don't care. All right. So what does that mean? Like, if it's Android uses activities. Okay. iOS uses controllers. They don't rely on MVVM as a core component of their framework. MVVM is model view model, and that's more of a Microsoft-centric technology, or really a architectural pattern for separating the interaction logic from the business logic. Okay, and I think it's really, really cool, and it makes things testable. And so again, I'm going to take what I've learned from building WPF and Windows Phone applications and Xamarin Forms applications, and I'm going to apply it towards everything. Why? Because it still provides that testable interface. So activities are going to forward requests to the view model, and controllers are going to forward the request to the view model. And the view model is going to forward that request to a model. The model is going to return something, and we test it, and that's the workflow that I use. And so I'm going to use that same type of workflow for this session as I attempt to share the technique that I use for testing confirmations, right? User confirmations. So let's get back. And I already said that there's 4 stages: setup, test, verify, teardown. We don't need teardown because it's done by our garbage collector. And I said I gave a dissertation on me using view models for everything. And so let's create our view model. Var view model equals new view model. Okay. And our view model is going to expose a confirm confirm command. Okay. Commands are essentially a design pattern that exposes an execute. All right. So they typically expose 1 or 2 methods. Actually, I think it's 2 methods from the I command interface, which is execute and can't execute. Right. And commands are popular within the user interaction when sending a request, right, from the user interface, or for sending a request from the user interface. So we have view model dot confirm command dot. I said they have an execute method that's part of the interface, and there might be some type of argument. I don't like using nulls for anything or checking for nulls, but the focus isn't on code smells using it with nulls. The focus is on testing a confirmation dialog. So the setup was we create a view model. The test was we execute a confirm command. You could think of a command as a request. And our verify is going to be our view model dot, I don't know, I would say is confirmed. Stop. Equals true. I guess you would have to wrap that in assert, right? Because this is our verify. I would like to say this. I would like to say assert is true that your view model that is confirmed is true, right? We can leave true out of it because it's confirmed implicitly means true. You know, if we're asking what the condition is, and that would be the high-level structure of the test. We're going to add in a little bit more setup, but initially we have a view model that's going to be the mediator between our view, or should I say our presentation, and our actual model. All right, this is going to be like the mediator, intermediary, and from our view, aka presentation, we're going to send requests to our view model in the form of a command. Okay, in this case, we want to do a confirmation. We want to do a confirmation, right? So the user will hit some button, right? That button can be viewed as a command or a request. Our view model receives that request in the form of a command. It executes that request in the form of through a command, and we then want to verify that the state of our view model has changed through one of its properties that gets updated through a side effect of executing this command. Okay. Let me silence my phone. And that's what we're going to do. So you might say, Scott, hold up. What you wrote doesn't compile. Like, we attempt to build it, and yeah, there's no view model. Like, what is view model? There's no view model. You're absolutely right, because we're doing TDD. Okay, we are test driving our business domain logic. Okay, we write the test first, and then we get the test to compile, and then after the test fails, we then implement the logic that's necessary to get the test to pass, and then we observe the test pass. Okay? So with that said, we can go ahead and create our view model file. Here's our view model file, our view model class specifically, and we're not ready to identify any constructors in here yet, so we should keep it as clean as possible. And that's our view model. Okay, so we created our view model, and now it's going to complain that, hey, your view model doesn't have a confirm command. Okay, confirm command. All right, so with that said, we need to create a property on our view model that is of type that implements the interface iCommand, right? But in this case, we're going to use a delegate command type, okay? And a delegate command type is a type that uses delegates. That's the best way I can explain it right now, because that is not go into detail about what delegate commands are. It's not the intent of this session, but just understand what commands are and understand that a delegate command leverages delegates. Okay, so we want to go ahead and create that. Right? I attempted to hit F12, which is going to the definition, but of course there is no definition because it was never defined. So we need to create a property for it. Okay, and here's our property right now. And if by default, I don't like mutating anything. And I'm going to call this, I'm going to call this delegate command. Okay. Delegate command is going to actually implement the interface I command, in which there's an execute and can execute, right? So now we need to flesh out this delegate command class, okay? We'll do that. So right now, I don't have the implementation with me. I don't have the actual code with me. I'm going to get it though. I'm going to get the implementation of it from NuGet. So, I like reusing anything that I built. So I have a bismonger.patterns, and it's defined. You see this delegate command right here in the description? Yeah, it's in this bismonger.patterns, right? I wrote this DLL, but you know what? I'm not going to use this DLL. I'm just going to temporarily bring it into my project, all right? And then I'm going to leverage ILSpy, and I'm going to view the implementation details of this delegate command class. And then I'm going to put that implementation on my clipboard, and then I'm going to uninstall this bismonger.patterns DLL because for you, I know I was preaching that we don't want to unnecessarily pull in these frameworks or tools, because frameworks or external tools, should I say external frameworks, external tools, they have this high probability of pretty much hijacking your code, and you have to perform all these ceremonies to make your code testable. And you end up, I find from personal experience that when you start getting external tool happy, external framework happy, you want to pull in all these different external frameworks and tools, I find I write a lot more ceremony. I have to write a lot more code to satisfy some type of requirement, right? And so, again, let's postpone these upfront decisions, and let's collect more information. Let's let more information trickle down as time goes by, as we're fleshing out our domain. And then eventually we'll have if we're ever confronted with having to pull in some external framework or use some third-party thing. If we're finally confronted, we have to make a decision. We have more information, but we're not going to do this up front. All right, we're going to keep software soft, okay, and not hard. So reduce the number of upfront decisions as much as possible. Okay. Now back to our scheduled program. So I'm going to temporarily bring in this bismonger pattern so I can get the implementation of this delegate command, and then I'm going to throw it away. Okay. So install. And I'm going to go to my bismonger.patterns because that's where my delegate command is. I'm going to go open in ILSpy, right, which is a decompiler, and I am going to find this delegate command, and here it is right here, and I'm going to put that on my clipboard. So on my clipboard, I'm going to close this window, right, and I am going to create a class called delegate command, and I'm going to fill it in with the data on my clipboard, the implementation on my clipboard. Delegate command. Stop. What was that? Hold up. Delegate command. Okay. And go ahead and did I do that? Yeah. All right. Nope. There we go. And it's going to complain about some things. So we import that stuff in here. I don't know what that is. Let me delete that. And import this system.windows.input that provides the I command interface. And my OCD is taking over. So by default, All members are private, so let's reduce the noise, even though we're never ever going to look at this again. Oh, and what else? We don't need this. Right? We don't need this because we have an underscore convention for our members. So let's get rid of that too. This is my OCD taking over, so you don't have to worry about this. Okay, and we don't need to tell the compiler something that the compiler can infer. Right? Well, the compiler already knows. You don't have to be explicit and tell it. It already knows. This can execute change as an event, but you know what? We should probably check if it's actually not null. And yeah, so good. Sorry, OCD still taking over. Yo, okay. So we clean up our delegate command class, right? Oh, yo, you go right here. Control KD will format it for us automatically, and we are good. Okay, and consolidate this, and we are good. Okay, yes, we're good. So we have an implementation, or we have a definition of our delegate command. All right, we can get rid of this bizmugger.patterns mayhem. We don't need it anymore. Okay, let's go back and let's go to installed. And we remove this bizmugger.patterns as some third-party DLL that some guy named bizmugger brought in. Let's remove that. Okay. All right, good. Now that we have our delegate command here, we can now close that. And it's pretty and colored, right? So now it's defined. And we can return back to our test, okay? And so our view model is defined, and our confirm command is defined. And this is confirmed. Well, that's supposed to be a property on our view model. But you know what? This is confirmed is supposed to really represent the confirmation results from the user, right? It's a confirmation result. And well, now that I think about it, like let's say we went ahead and used this as a bool. That's fine, right? But my OCD says no, Scott, it's not fine because it's confirmed. It's not a bool. It's confirmed as a type. It's confirmed is a result, right? It's a type. So maybe it doesn't matter. It doesn't matter, right? But for me it does. So so let's call this confirmation result. Yeah. Okay. We make that a type. Yeah. And I guess we should rename is confirmed to confirmation results. Yeah. And so we have this view model dot confirmation status. Yeah. Okay. And I guess we can update that. Confirmation status. It's a confirmation result. Confirmation result isn't defined. So we need to define confirmation result. So for us to define confirmation result, we go ahead and create a class, and we can say that this confirmation result is not a class. This confirmation result is an enum, and this confirmation result enum is confirmed or it is canceled. Okay. Now we define our confirmation result. Okay, it's defined in here in our view model as a property. Okay, it's internal set, man. Like I don't want any mutable properties in my code. Okay, all right. So we have confirmation status. It's going to basically return the confirmation result. We return back to our test, and our assert dot is true, viewModel.confirmation status is incomplete. It should equal this confirmation result dot confirm if we want to have the agent of the outside world return a confirm status to our confirmation request. Okay, so with that said, well, yo, hold up. Does everything build? Everything builds. It says build succeeded right here. Cool. All right. So let's run our test. Yeah. Go. All right. Red, green, refactor, and we get a red. All right. And it says it through some type of exception. It said through some exception, right? But it doesn't matter, right? Because we didn't really define anything. So it's going to be red regardless if it throws an exception. So let's think about where we're at right here, okay? We have this test method, okay? And this test method has our setup, tests, and verify. And we have this view model, and then we have this viewModel.confirm command, and we execute it, right? But when we executed this confirm command, what did it really execute, right? Like, we didn't actually identify we didn't actually provide an implementation of what it means to execute this confirm command. Okay, so what we wanted to execute, let's go down here. All right. So like, okay, here's our class. This is a view model. Okay, now well, maybe we should actually do something to make the confirm actually execute. All right, we need to provide an implementation for what execute means on our command. Okay, so let's do a constructor, and let's say, all right, confirm command. I want you to execute this anonymous method, if I can say that, of something, right? I want you to execute. And what I want you to execute is I want you to, I guess I need you to execute some type of confirmation. I guess we need to expose a confirmation to an agent of the outside world. Okay? So if an agent of the outside world performs some type of action or some type of operation on the user interface, maybe that user interface should then provide them with a confirmation asking them if they want to move forward. Okay, maybe it should be that type of workflow. All right. So if we ask them if they want to move forward, then what we're really doing is we're providing them a confirmation. Okay. If we're providing them a confirmation, then it should probably be like a confirmation that we're providing them, and we should say confirmed, huh? Something like that. And that will basically expose some type of interface to the agent of the outside world to react to. Yeah, okay. All right. Okay, but this isn't defined. Okay, well, let's say it is defined. Let's define it. Let's say I confirmation. And confirmation. Okay. Yeah. It's I confirmation, confirmation, all right? Well, that doesn't really look right. We probably should, because this is its own method right here, and it has no clue what this confirmation is, because this is really a method. This is a method. It's an anonymous method. So this confirmation, I think, I'm not a guru, but I think it's out of scope. So what we need to do is we need to create a member I almost typed in member. We need to create a member called confirmation. Okay. Confirmation equals confirmation. That's passed in. All right. Yo. But hell's bells, Scott. Like I confirmation, that's not defined. This confirmation, it needs to be lowercase. That's not defined either. Well, all right. Well, one step at a time. One step at a time. Okay. So let's go ahead and define this confirmation. Oh, all right. Let's define it. And we have this public interface I confirmation. Okay. And this I confirmation is going to provide or expose, confirm. So let's expose a confirmation result. Yeah, called confirm. All right, so it exposes a method called confirm, and it's going to return a confirm result, confirmation result. Yeah. All right. Good. All right. Okay, well, how's it going to return the result though? Like if you hit confirm, all right, if some implementation that implements this I confirmation also has a confirm method, and that method is invoked, then okay, well, how do we actually like expose that to a user? How do we say that, hey, we need a confirmation? Well, maybe we just answered it. Hey, we need a confirmation. So, hey, let's raise an event called request confirmation. But we're already in the context of a confirmation, right? So I confirmation.request confirmation? Nah, man. It's I confirmation.request. Confirmation.request. Let's call it. Okay, let's create a delegate. And we say public delegate confirmation results. Yeah, is request. Okay, on request handler. Is this a delegate? All right, this is going to handle it. Request handler. Okay, what am I missing? Oh yeah, I need that right there. All right. I'm not going to take in any arguments. Okay. No parameters. Request handler. Yo. Then we're going to in our I confirmation interface, for any class that implements this interface, they also need to expose an event. That event is going to be called our it's going to be called event. This request handler, yeah, and it's going to be called request. Yeah, there we go. Yeah, okay. Yeah, so we have an I confirmation interface. This interface is going to expose a method, expose a contract in which all classes that implement this I confirmation interface, they need to basically have an implementation of confirm, okay? And we need to somehow report that a confirmation is needed. So we define an event. We declare an event called request that all classes that implement this interface, they have to have, okay? I think I'm there. It's a little bit fuzzy, but I think I'm there, okay? So let's go back to our test, our underscore confirmation, and now our view model has a red squiggly. Why? Because there is no empty constructor. There's a constructor that requires an I confirmation. Right? And if we go into this view model's constructor, we will see that there's a confirmation member. Did we define that? There's no definition for this confirmation member, right? So, well, okay. Let's create that prop and say confirmation. Well, confirmation, and call that confirmation. So we take the interface that we recently created or defined, and we make a member out of that interface within our view model. Okay. I hate mutating my members or anything. Okay. Get rid of that set. All right. I don't want to modify anything. Okay. So yeah. Okay. Now, so that's not public. It's private. Okay. And by default, it's private, so we don't have to have the keyword private for this member called confirmation. Okay. And what's happening here? They call it execute, and we say confirmation. Yeah, confirmation is a member. Say confirmation.confirm. Okay. Now there's still a red squiggly on here. Cannot convert lambda expression to type object because it's not a delegate. Okay. So what does that mean? Let me go back and this confirm. It's a result. Okay. What does this red squiggly mean? Right. Can I say this is a lambda? Okay. Can I say return? Oh, do I need to say that? Oh, it's not return. So what are you talking about? Okay. Now, I need to resolve this red squiggly. It says cannot convert lambda expression to type object because it is not a delegate type. So what does that mean? All right. Well, let me try to dumb it down and just say that our confirm. Let me try to dumb it down, all right, and I'll get back to this. I don't have the answer to this right now, but I can say that I can do this. Object parameter. Oh, maybe that was it. Hold up. Is it this? And it is, I don't know. Hold up. So let's try to resolve this by saying on confirm and do that. And oh, what the freak? Execute object on confirm. If we look at the definition of execute, this is getting on my nerves now. If we look at the definition of execute, it should be object and it's an action. And so that should, well, before we do this, we should probably do this. I get it. Yeah, that's my bad. All right, so we should, come on, Scott, you gotta get it together. All right, so we first need to, within our constructor, we need to create an instance of our confirm command. So confirm command equals new delegate command. Yeah. And then in here, we can say, we can say confirmation dot confirm. Okay. And what is it talking about? I'll put that in there. And it, okay, good. Oh, I guess it's been a while. Okay. So now we have our view model. We pass into our view model constructor, a confirmation interface, and then we set a member to that interface. And when this confirm command is invoked, we will take that confirmation interface and call the confirm on it. Okay? Yeah, let's go back to our test. Man, I got in trouble for a second. This view model, there's no such thing as an empty constructor for this view model. It needs some type of confirmation object, really an interface, right? So let's go ahead and say var confirmation equals new. Oh, hold up. We can't say new I confirmation. We can't do that, all right? This is an interface. You can't instantiate an interface. So we need to create a concrete class that implements this I confirmation. We'll call it mock confirmation. Okay? And then we say generate class. Okay? And public. And what else? We could say this mock confirmation is going to implement I confirmation. Okay, and it is going to implement that. And let's get rid of this unused constructor. Good. But you know what? It needs to raise this event, this request saying, hey, I need a confirmation. That's what our mock confirmation needs to do, I think. I guess I'll find out sooner or later. Request. Okay. But you know what? That request, it can't be null, so we need to check if it's null and then invoke the event. Okay. Now, it says it doesn't return anything. You're absolutely right, because we didn't return anything. So, like I said, Control D, format that. And what's going on? Why? I thought this request returns a confirmation result. A confirmation result from this request handler, but it's complaining. What is it complaining about? It says cannot implicitly convert type confirmation result to what are you talking about? What is it talking about? This confirm should take this request. It says it can't cat. How many confirmation results do I have? Just confirmation result. That's the confirmation result there. And I'm not sure what this is complaining about. It says cannot implicitly convert type my test confirmation result to my test confirmation result. It has a question mark at the end of it saying that it's nullable. Okay. So it's not nullable. Yeah, that's weird. Okay, so it's not nullable. What are you talking about? Let's go back. And let's just return. In this request, we can say, yeah, I don't understand that. Does that make it happy? That makes it happy. All right, I have no clue. Yeah, I can't explain it. But anyway, we move past it and let's keep going. Okay. So what happened so far is we create a mock confirmation, and this mock confirmation implements this iConfirmation interface. To implement the iConfirmation interface, you have to implement the event called request, and you have to implement the confirm, right? When implementing the confirm, we will invoke the request. We will raise the request event. Okay. Let's go back to our test, and this view model still is hungry for our confirmation interface. So we take this confirmation instance that implements the confirmation interface, or aka iConfirmation. We pass it in there. Okay. Yeah. And then what is this execute complaining about? This execute says the call is ambiguous between the following methods or properties. Delegate command.execute, and what the freak? Why I keep getting this? They both look the same to me. They both look the same to me. So, what are you complaining about? If I try to build delegate command, already defines a member called execute with the same parameter types. Okay. What is this all about? Now is our delegate command. And didn't all this like compile before? I'm almost positive all this compiled before. If we debug this, now I'm a professional debuggerer. And I don't know what this thing is talking about. There's an execute up here. Is that what it's complaining about? And everything builds. Okay. Not sure what that was about, but whatever. Don't focus on delegate command implementation. You can look it up on the web and you will get the implementation. Or I could provide it as a link. Okay. So that stuff builds. Now let's go back over here. Let's bring this back. And let's see if it builds. I don't see any red squigglies, and that builds as well. Okay, good. Now, let's run the test. And when we run the test, it should still fail because we didn't really do anything. Oh, hold up, it passes. Why did it pass? What did we do to make it pass? Okay. What did we do to make it pass? Well, by default, it is 0. All right. What if we changed? What if we changed this? By default, it's 0. All right. So let's go back here, and we don't want it to pass like that, right? So maybe we were doing something that wasn't meant to be done. We shouldn't. It's not good for something to be confirmed when we didn't explicitly confirm it. So that said, let's say waiting. Yeah, let's create another enum member called waiting. How about that? Yeah. Will this test still pass? Oh, okay. That's a lot better. So we got a bug, right? hopefully, as a professional developer, you wouldn't have taken that passing test and said, oh, okay, cool, it passes now. No, you need to always challenge and scrutinize your code for the absolute truth, okay? So in this case, we had added just enough implementation for our test to pass, but we said that wasn't right. You should not be passing it because we didn't really do anything for you to pass except make the compiler happy. All right, so with that said, look at me, I'm trying to say. With that said, is that really happening what I'm trying to say? Okay, so with that said, we need to make this test pass, all right? We have our confirmation result options or possibilities defined as waiting, confirmed, or canceled. And we need to make this test pass. Okay, so how do we do that? Well, hold up. This mock confirmation raises an event called request. Okay. And this execute will, if I go to my view model, we'll do a confirmation.confirm. Okay. Okay. But you know what? Our confirmation needs to actually handle the request, right? So like the agent of the outside world is our unit test. This is the agent of our outside world. And we're going to say that when a confirmation is requested, we, the agent of the outside world, are going to say, hey, no problem, I got you. Confirm. I confirm. Okay. And then, so when this request does get raised, we handle this request as if we are the agent, as if we're the user, and we're going to confirm that yes, we want to proceed. And that request is going to, after we confirm, we will probably do something like this, right? Probably do something like this. I should go to this. And yeah, you probably need this over here. Okay. And so what we probably want to do is set the confirmation status to, can we do that? Confirmation status. We can't do it. Why? Because early on I said I don't want my properties being mutated, right? Maybe I don't want the outside world mutating my properties, right? Changing the state of my view model. So let's do a private set. Okay, that makes it happy. And maybe I can just, I'm not sure how pretty this will be, but maybe I could just do something like this. Yeah, okay. So now that we have that in here, what we did is we have a constructor, we have a member called confirmation. When this confirm command actually gets invoked, when it gets invoked, all right, say we have like a Xamarin app or a WPF app, and they hit a button that somehow, or they do something, I don't care, that in this case it's going to be a button because a button maps to a command. When they hit that command saying submit, maybe there's a are you sure confirmation or whatever it is. And what we're going to do is we're going to call confirm, right? We're going to call confirm on this confirmation object. Now, this confirmation object, like right now, it's sitting behind an interface, right? But actually, in our test, our confirmation object is a mock confirmation. And so, what our mock confirmation is going to do is it's going to raise a request event, and that request event is going to be shown, it's going to be exposed, for lack of a better term, to the agent of the outside world, which happens to be our unit test. And so we subscribe to this confirmation request, right? And we say, hey, when there's a request that happens, we want to handle this request event, all right? And we're going to handle it by saying, yes, we confirm this confirmation that you're requesting for us. We confirm it, okay? And so we go ahead and we execute that command. This should go ahead and raise that request event. Since we subscribe to that request event, we say we confirm, that gets returned as a result of handling that event. And we are going to verify that the confirmation status is set to confirmed. It sounds good in my head. I'm just not sure if it's going to work out, right? Let's see. So, the last test we ran, it failed based on a default. We updated that default. And now it should do something like hopefully pass. If it doesn't pass, then I don't know. But it passes. Yay! All right, so the test passed. Okay, yay. Okay, now let's step through the code and let's see what really happened. Again, the session is about unit testing a confirmation, unit testing a user interaction through a confirmation interaction, a confirmation dialog. Okay, so let's go back. Set up tests and verify. We're going to step through this code. Okay, and we are going to. Well, we can always use the shortcut Control-RT within the scope of our method to launch that specific test, to execute that specific test. And we're going to start stepping through the test. We have our mock confirmation object that we just instantiated, right? And we're going to go ahead and register for an event on this confirmation object called request. And we're going to say, hey, when we receive a request from this confirmation, we're going to say, yeah, go do it, okay? And then when it gets done, we expect that our confirmation status on our view model is going to now be set to confirm. It's going to reflect a confirm status, okay? So we want to go ahead and register for that request event, saying we're going to return confirmed as the agent of the outside world that you're raising this event to. And we're going to go ahead and now declare, instantiate our view model. To do that, we hit the constructor of our view model. We passed in an interface for confirmation. We set that interface to a member within our view model so we can hold on to it, thus giving our view model some states. And when we do that, we want to say, hey, confirm command, let's go ahead and instantiate you too, all right? And when we actually invoke you, this confirm command, we want you to go ahead and execute this confirmation member's confirm method. We want you to execute this confirm operation of this confirmation member. And when we do that, we should receive from invoking this confirm some type of confirmation status, okay? And we're going to set that confirmation status, right? So we get a confirmation result. That's what I should really say. And when we assign that confirmation result to our property right here called confirmation status. Okay. Yeah. All right. And that's our delegate command. We don't care about the implementation details of that because it's a third-party entity, for lack of a better term. And we don't test third-party stuff. We just expect it to work. Honestly, I don't like bringing in third-party stuff. But all right, so we instantiated our view model. In our test, we're going to test the invocation, if I can say that, of our confirm command. And the side effect of executing that confirmation command should be us receiving a state of confirmed for our confirmation status. Our confirmation status property on our view model should reflect the execution of this confirm command, in which we return a confirmed status, a confirmed enum value, okay? And so when we execute that, we're in our view model instance, and this delegate command is now being executed, and we say this confirmation status property of our view model will be the result of our confirmation confirm. You see that right here. If you step into that confirmation.confirm, we hit our mock confirmation. That's the implementation of the interface that we're sitting behind, and our request is not null. It has a subscriber to it. We invoke that request. The agent of our outside world, which is our test method, says, hey, here request, we've been notified, and we're going to go ahead and say, yes, we do confirm by saying confirmation result.confirm. We're going to pass that as the answer to this request, our answer to the request, and we're going to go ahead and step through that. That's happy. That's happy. That's happy. That's happy. And we're going to assert that the confirmation status is confirmed via us answering the request of do we want to move forward with confirmation. And that's happy as well. And the test passes. Yes, the test passes. And let the test explorer do whatever it needs to do. There's some overhead. I'm not sure what it was doing during that time, but we get a green check mark. Yeah. What did we do? I just stepped through it, right? What we did was we flushed out the business logic for managing a confirmation, okay? In this case, we just used a mock confirmation object, right? But this mock confirmation object can easily be an actual domain confirmation object, right? It just happened to be mocked out right now because I don't know the details of it. But that's how you do it, right? Now, moving forward, I'm going to demonstrate how we take this test that we just implemented, right, via TDD, right? Of course, it's a test we implemented not after we wrote the code, but before we wrote the code. It's TDD. And in the next part of this, I was almost say symposium. This next part of this dissertation, I am going to discuss the refactoring, right? RGR, red green refactor. I'm going to discuss how to refactor the classes, the code that we came up with to make this test pass, and I am going to wire up the UI, right? The actual application to this flushed out logic. That is what I'm going to do next. So let's move on to the other part.